Okay, 3.2 Principal Inverse Trig Values video lesson. Let me explain what a principal value is, and then I'm going to do a little recap of the activity we did over restricted range. So the principal value, when I use this word in this context, I'm talking about an inverse trig function, and it falls into that function's restricted range. So you have to follow the restricted range rules to find principal values. It says, since there are an infinite number of angles for each ratio of sides, and by the way, when it says infinite number, what I'm talking about is there are many times when we did exact values and you got the answer of 1/2 or negative root 3 over 2. There were many different angles that fit, and that's why we have to follow these rules. Your calculator will always do principal values correctly, but you're going to get a really messy decimal answer. And let me back that up. There's actually one exception. Your calculator does not like cotangent, and I'll explain this why as we recap this box. So when we're doing inverse sine, remember from the activity that the restricted range falls between negative 90 to 90, which would be quadrants 1 and 4. And we know that in the first quadrant, everything's positive. That means you take sine of an angle in the first quadrant, you get a positive exact value, which means that if we're going backwards and we're taking an inverse trig value or an inverse sine value of something that's positive, we're going to be in the first quadrant. And if it's negative, it's going to put us in the fourth quadrant. Okay? And instead of going all the way around to do that, we're going to do this nice and easy, and we're going to be able to just go reverse angle, which means we're going to put a negative in front. And you'll see that more clearly in the examples that we do. Obviously, second quadrant would not make sense for sine because it's also positive. And third quadrant, though, although it is negative for sine, it's not something that we're going to use at all for any of the trig values. So we're going to always stay in quadrant 1 and then maybe go to quadrant 2, maybe go to quadrant 4, depending on which one. And notice that for arc sine and arc cosecant, they do have the same restricted range. We have this y not equal to 0, but the restricted range is basically the same. So that makes sense since they're reciprocals. All right, for arc cosine, we have a different restricted range. We go from 0 to pi. So again, if what we're talking about is positive, we're going to stay in quadrant 1. And if what we're talking about is negative, we're going to go to quadrant 2, which makes sense because according to our sine chart, our all students take calculus, cosine's negative in the second quadrant. Okay, and again, it also is negative in third. We don't deal with the third. And arc secant is just like arc cosine. We have this little exception here for the asymptote, but it won't change the restricted range. All right, now for tangent and cotangent, it's a little bit different because they don't follow the same rule. All right, tangent actually follows in line with sine. It is much more like sine than it is cosine, and one way that might help you think about this, I'm kind of oversimplifying with what I'm about to say, but remember how sine started with a middle point when we graphed it, and so did tangent? That can maybe help you remember that the restricted range of arctan is the same as the restricted range of arcsine. So again, we're going to be from negative 90 to 90, and positive puts us in quadrant 1, negative puts us in quadrant 4, and cotangent, not the same. So arc cotangent has a different restricted range. We saw why that was when we were dealing with the inverse trig graphs and we were using the mirrors to do the reflection. But for arc cotan, it's like arc cosine. And you got to do what you got to do to help memorize this. So cotangent is actually like arc cosine and arc secant. And so if you study this material a little bit each day, you'll remember it. If you get your restricted ranges mixed up, just over here off to the side, remember that your all students take calculus. It may help you remember what arc sine and arc cosine and their reciprocals are. When it comes time for tangent and cotangent, you're going to have to either go back to how we did it in the beginning, or my advice is just to memorize this information. Okay, so let's go ahead and just look at an example. Oh, one thing that might help you here before we move on with the notes is to redraw your 30, 60, 90, and your 45, 45, 90. Okay, more often you draw these triangles, it's going to stick with you. You're not going to make that mistake if you're drawing them quickly on a test. By now you should be experts at drawing these triangles. Okay. OYO chart might come in handy. We'll draw that as needed though. Alright, so let's look at the example. The directions say to find the exact principal value, alright, and a lot of times I'm going to abbreviate this with PV, in radians. Okay, so we can think in degrees a little bit, but our answer is going to be in radians. It says without using the calculator. Alright, now before when we did arc sine or, you know, the sign with the -1 here, which means arc sine or inverse sine, we got to use a calculator. But what makes this different is that I'm giving you values that you're familiar with. So if you remember, if you have things memorized and you can recall them, this is going to be a lot easier. So if you know, if I say sine of what gives me square root of 3 over 2, and you can recall quickly that that's 60 degrees, this is going to be much easier for you. If you don't remember that, then you're going to have to go back to your 30, 60, 90 triangle and figure out, is it the 30, is it the 60, or is it, in some other cases, it could be the 45 degree, or possibly the OIO chart. It's going to be one of those things, though, if I tell you to do this without the calculator. So this is 60 degrees. That is our reference angle. So I'm going to go ahead and write theta reference, and that is 60 degrees. And that's awesome. That doesn't give me my final answer, though. First off, I need to put this in radians, and in radians 60 degrees is pi over 3, and this should be just second nature by now. The other thing is, if what you're taking inverse or arc sine of is positive, you just get to leave it as pi over 3. So I'm going to go ahead and box it. If this had been negative, though, I would have to place it in the correct quadrant using the restricted range rules. So that's what problem number 2 has. So again, just ignoring the negative for a second, if you remember that sine of 30 degrees gives you 1/2, that is going to be your reference angle, and I'm writing this down here. I probably won't write it down on every example, but this doesn't hurt to write this down. But since there's a negative there, you've got to remember where the restricted range is. For sine, it was -90 to 90, or negative pi over 2 to pi over 2. All right, if this had been positive, we'd stay in quadrant 1, we wouldn't even have to mess with it. But since it's negative, we got to go to quadrant 4. Now the nice thing is we don't have to go all the way around. We get to just remember that in quadrant 4, it's basically the same angles as in quadrant 1, but negative, because you're going in opposite direction. So 30 degrees is pi over 6, so my answer here is negative pi over 6. Okay, let's look at the next one. Arc cosine. All right, at least I don't have a negative in the inside of the parentheses, so I don't have to worry about restricted range. But I do have to recall what the angle is. And the reference angle here is 45 degrees. So you just have to write that in radians, pi over 4. Okay, if this had been negative, we would have to place it in the correct quadrant. We'll get more practice on that. All right, let's look at example 4. Arc cosine or inverse cosine. Here we have a negative. Let's first, though, just think, what is that reference theta, reference angle? Okay, so again, if you remember it, it's much easier, 30 degrees. If you don't know it, you're going to have to go to your 30, 60, 90 triangle and then think about your SOHCAHTOA and figure out, is it 30 or is it 60? Okay, so it's 30 degrees. This is going to be pi over 6. However, I'm not going to write that down yet because if you remember for cosine, our restricted range is from 0 to pi. First quadrant if it's positive, second quadrant if it's negative. So we need to place 30 degrees into the second quadrant here. Alright, so remember that 30 degrees is pi over 6. So in the second quadrant, pi over 6 becomes 5 pi over 6. Alright, now if you're a little bit confused about how that happened, I'm going to take a minute just to explain this on this one, although I think you should be to the point where you can do this. Remember that all the way over here would be pi. So if my reference angle is pi over 6, this little angle right here that I'm coloring in, if that's pi over 6, then I would basically be doing pi minus pi over 6. And that would be 5 pi over 6. You're never going to do pi plus the reference angle for what we're doing today, which are principal values, because we're never going to go to the third quadrant. So if you're in the second quadrant, it's always going to be pi minus the principal value. But like I said, I think most of you've done this calculation so many times on other problems that you're pretty quick at it. Okay, let's look at a tan problem. So on number 5, we've got arctan square root of 3 over 3. So you know that's either going to be 30 or 60. If you do not remember what it is, okay, you're going to have to look at a 30, 60, 90 triangle and decide. This one in particular is one that's much easier if you just have it memorized, because if you're looking at a triangle, what you really should be looking at here, you're not going to see square root of 3 over 3. You're really going to see 1 over square root of 3, because this inside right here has just been simplified. Okay, so if you do decide to draw a triangle on this one or look at a triangle, okay, 30, 60, 1, root 3, 2, opposite of 30 is the 1, adjacent is the root 3, so it's 30 degrees. 30 degrees is the reference angle. But again, truly, if you have the exact values memorized that I've told you to many, many times, this is so much easier to do. It's not about giving you more to do, it's about making your life easier if you just memorize the few things. So remember that arctan restricted range is like sine restricted range, which puts you either in quadrant 1 or quadrant 4. Now, I drew this here just to kind of remind you, but I really didn't have to, because this has positive value right here, okay? The ratio is positive, so we know we're going to be in quadrant 1, which means all I got to do is change 30 degrees into radians. That's going to be pi over 6. And there's our answer. Okay, number 6, I am going to have to be concerned about the restricted range, but first let's figure out what our reference angle is. Now, we just did one like this. This is the reciprocal. So that means our reference angle is going to be 60 degrees. And again, you may have that value memorized, and that would be more beneficial to you. Okay, again, arctangent, we're either going to be in quadrant 1 if it's positive, but if it's negative, like this example, we're going to be in quadrant 4, which means we're just going to make 60 degrees negative 60 degrees, and always remember to turn this into radians on this worksheet anyway. Typically, we're going to start working in radians most of the time. I would say about 80 to 90% of the time. Okay, number 7 looks interesting because it's not from a 30, 60, 90 triangle. It's not from a 45, 45, 90 triangle. It's from the OIO chart. Okay, so I'm going to, I noticed on the last test some people were not writing the OIO chart correctly. So I'm going to remind you what that is. Okay, so that's O-I-O, I-O-U, O, I don't owe you. What I find is the biggest mistake here, though, is that some students are not writing these angles down, and they get confused on whether you're starting with 0 or starting with 90. Okay, on this problem, you got to remember what you're starting with. You're not starting with an angle, you're finding the angle, because we're essentially working backwards on all these problems. We're given the ratio, we're finding the angle. So you don't want to look at the angle 0 degrees, you want to look at where sine is 0 on the chart. Now in this case I have 2 different values. So we've got to think about, well, what is the restricted range of sine? Our final answer has to be right in here. So I couldn't pick 180. 180 would be over here. That does not make sense, okay, with my restricted range. So I have to pick 0 degrees. Now, hopefully you caught my mistake. I did, at least before I boxed it. 0 degrees is right, but really we want to be in radians, which we would just write 0 and not write the degree symbol. I know this seems like a minor detail up here, by the way, but it's hard because 0 can be degrees and it can be radians and it can be the ratio. So we've got to really keep straight what this chart is telling us here. Okay, back on number 8, we're just dealing with 30, 60, or 45 again. So this is arc cotangent, and we remember that arc cotangent has a different restricted range than arc tangent. So let's first just find the angle. Now you might or might not have this memorized. So again, let's make it into a ratio. Anytime we're not sure, either just because we didn't have it memorized or because it just seems different than the others. This looks like a 30, 60, 90, so I'm going to draw the 30, 60, 90 again. And we're looking at the angle for TOA. For opposite of TOA would be adjacent over opposite, because this is cotangent, not tangent. So adjacent for the square root of 3 and opposite for the 1 would be 30 degrees. That is our reference angle. And if you're finding the reference angle easy, that's good, because that's ultimately the hardest part here. The only other thing that you're having to do is determine then what quadrant you're supposed to be in. So remember, for cotangent, it has the same restricted range as cosine, okay? Not like tangent and sine, but cosine. So if we're positive, we stay in quadrant 1, and we don't even have to mess with this whole what quadrant are we in. We just change our answer to radians, and we're done. But because of this negative right here, we have to know that we're in the second quadrant, not the fourth. That would be the common mistake here. We're in the second quadrant. So again, all the way over to 180 would be pi. So really what you're doing here is pi minus, in radians 30 degrees is pi over 6. So that would be 5 pi over 6. We haven't had one yet. But what would 30 degrees be in the second quadrant? Okay, it would be 2 pi over 3. And that's just going to take a little bit of practice. It's not anything we haven't done yet. It has been a while, though. Okay, let's look at number 9. So on number 9, I see arc cosecant. So what I'm going to do, I didn't do it here for arc cotangent, because arc cotangent is not like arc tan. They're different restricted range. But since arc cosecant does have the same restricted range as arc sine, I am going to write this. Okay, arc cosecant of negative root 2 is the exact same as arc sine of negative 1 over root 2. Okay, or you may see this written as negative root 2 over 2. Sorry about that. And so we know this is a 45 degree. All right, so that is our reference angle. Our reference angle is 45 degrees. And we haven't had one of these yet, but we know that that's going to be pi over 4. And because arc sine, its reference angle, puts us in to quadrant 4, okay, we don't have to do much. We just have to tag on a negative. So it's going to be negative pi over 4. Let me try to make my 4 look a little bit more like a 4. There we go. Okay. Arc secant of negative 2. Okay, this is the exact same thing as arc cosine, or inverse cosine, of negative 1/2. Alright, they have the same restricted range. Notice that I did flip the ratio. And our reference angle, these should be coming a little bit quicker to you now. What is the reference angle? Write it down, see if you can beat me. 60 degrees. For arc cosine, remember that we go from 0 to pi, so since it's negative, it's going to be in second quadrant. So this would be pi over 3. All right, so I'm going to go ahead and write it out. Pi minus pi over 3, that would be 2 pi over 3. Okay, then we get to number 11, and you might be looking at this negative 1 and thinking OIO chart. And if this had been arc sine or arc cosine or even arc secant or cosecant, you would be right. But remember that tangent of 45 degrees is 1 because of the nature of the 45, 45, 90 triangle. So our reference angle in this case is 45 degrees. Now because of the negative, you got to remind yourself of your restricted range. We need to be in quadrant 4 for arctan of a negative, and so that's going to be negative pi over 4. Okay, and last example, if you want to try it, you could pause and write it all down and see if you get it right. So we have the reference angle. This is going to be 45 degrees. So then for cosine, 0 to pi puts us in the second quadrant. And I'm going to go ahead and write this out. Pi minus pi over 4. That is going to be 3 pi over 4. Okay, so turn the paper over. Let's recap this lesson. If the ratio of the sides is positive, then the answer is, well, there's many things you could actually put in this blank. It is the reference angle. It is positive. And I'm going to go ahead and write all those things down. Positive, theta ref, keeping in mind that you would change to radians. But if the ratio of sides is negative for sine, tangent, and cosecant, or rather arc sine, arc tangent, arc cosecant, okay, this is where, if you remember, we go from negative 90 to 90. So for negative, we go to quadrant 4. So the answer is just basically the negative reference angle. And the reason is because we can go to quadrant 4 the quick way by just going the opposite direction. Okay, for the other three, the answer is, well, let's draw this out. Remember that these have a restricted range from 0 to pi, so it puts you in quadrant 2. So your answer is going to be positive. Do you remember how we found the answer? We did pi minus the reference angle every single time, and our answer was positive on that. Okay? Your calculator will do all of these. So let me back up one. Whoop, not that far. If you were, say, on number 11 to type in arctan of -1, if you are in degree mode, it will give you negative 45 degrees. If you are in radians mode, it will give you the equivalent of negative pi over 4. It's going to be decimal. You won't rationalize out by hitting math fraction or anything, but you could still then type in negative pi over 4 and see if you get the same decimal. All right, your calculator will tell you the truth about every single one except one. Do you remember which one I said your calculator will lie to you about? It was cotangent. The reason? Let's think about how you would type in arc cotan. In your calculator, arc cotan would be arctan, and then you do 1 divided by whatever, or you would flip the ratio that's there. So if your calculator knows the restricted range and uses them appropriately, when you're trying to do arccotan, your calculator is actually using the restricted range for arctan, which is different. Okay, so moral of the story here, you want to put like a big arrow, your calculator will lie. And it's not really your calculator's fault, it's the way that you're using it. But your calculator lies about arc cotan principal values. And if you remember principal values, that's what the whole lesson was about. Okay, so bring questions to class tomorrow.